Hi there. This is help with 7.2, adding and subtracting rational expressions. When we're looking at this, rational expressions are, of course, fractional expressions, and so you treat these just like you do with fractions. The same rules apply. So in this first example here, I am subtracting two fractions, and so remember, to subtract or add fractions, I have to have a common denominator. This one I'm in luck because I already have that common denominator. It's an x plus 7. Now when you're subtracting, though, the reason I put this one in here, usually when you are adding or subtracting, for instance, if I had a 4/5 minus a 2/5, all you do is subtract the numerators and leave the denominator alone. So 4/5 minus 2/5 is just 2/5. Okay, but what you have to be careful with on this is that we are subtracting this entire fraction. So that means when I'm subtracting, it affects everything in this numerator. The denominator stays the same, but the numerator is what I'm really subtracting. I tend to like to change, anytime I have a subtraction, I change it to an adding the opposite. And I do that with everything up there. You have to change the sign on all of those. That way I remember, I don't forget, oh, I was subtracting, that affects everything. So what I would end up with on this problem then is an x plus 7 for my denominator. And on the top, I have a 2x plus a 3 minus a 4x and minus a 5. And then you look to combine any like terms up there. I've got a 2x and a negative 4x. That's negative 2x. I've got a 3 and a minus 5, so that's minus 2. All over x plus 7. And you've got it. Now that's kind of nice because you already have the common denominator. Let's look at an example when you don't necessarily have a common denominator. And let's start with just working with numbers, and then we'll apply that reasoning with something with some variables in it. If I have a 4/5 plus a 3/5, you have to get a common denominator. So you have to figure out what will 9 and 5 both multiply into. And it'd be 45. So this one I have to take times 5. But you got to do it on the top and the bottom because you're really multiplying by 1. It's just, you're writing it as 5 over 5. Over here, to make this be a 45, I'm going to multiply by 9 over 9, which is really just multiplying by 1. And so then I end up with a 20 over 45 plus a 27 over 45. Now you have the common denominator, so you write the denominator and you add your numerators together, so you get 47 over 45. Now that's a review of what you do with just numbers. Let's try it with some variables. All right, in this example, I have an x minus 5, but then I have this other quantity over here. Anytime you come across these quantities, especially like a trinomial, kind of a big clue would be to try to do some factoring of that. So before I try to get my common denominator, I'm going to factor. So this would become x and x, 5 and 3, signs are both minuses. And leave the numerator alone. I don't care about that. It's the denominator I'm working on. And how convenient is this? I ended up with an x plus or an x minus 5 term here, just like I had over there. So what I'm looking to get for a common denominator would be something that both of these multiply into. Well, this right here, this x minus 3, x minus 5, looks very nice. But over here, the x minus 5 term, I need an x minus 3. So what I'm going to do is take this side times an x minus 3. But you got to do it at the top and the bottom. So then I end up with, take that 2 and distribute it, 2x minus 6 over x minus 3 times x minus 5 plus, don't have to do anything with this side because it already has that common denominator. Alright, now you have the common denominator, you merge it together and just add your numerators together. The denominator stays the same. I don't have to worry about my sign on this one because it's a plus. So really I'm going to have a 2x minus a 6 plus a 3x minus a 19. And really I'm going to go ahead and save myself a step here, and I'm just going to combine my like terms at this stage. I've got a 2x plus a 3x, that's 5x. I have a negative 6 that I'm going to add to a negative 19. That's going to be a negative 25. Now, what did not happen last time that you need to always kind of be on the lookout for, in this example, I have in the numerator a 5x minus 25, and I could call it quits, but it's kind of nice to think back to what we had done previously where we were multiplying and dividing. In this one, I'm going to go ahead and look and see, because I noticed in my numerator I could factor a 5 out of that. Now sometimes that doesn't matter at all, and there's nothing you can do with it, but look at what's going to happen on this one if you factor that 5 out of there. You end up with an x minus 5 term. Well, you have an x minus 5 term on the bottom also, and any chance you can to reduce, you want to do that. So because we're multiplying right there, we can cross this whole thing off with this whole thing, and it actually reduces to just a 5 over an x minus 3. And now you're finally done. Now sometimes you'll be able to do that extra step at the end where you can factor something out and reduce. Sometimes not. It's just something you have to be looking for. Good luck.